Unit 2, Segments, Lines, and Angles. Preview video 2.8, Proving Parallel Lines. Take a moment, ready, inhale, deep breath, hold, and exhale. Don't forget date, time, and location. Highly recommend you have colors handy, as well as your stir sticks. Don't forget date, time, and location. Parental sign-off. Let's recap. Last class, we learned this. If you have parallel lines, then you have a bunch of different, I'm just going to write the words, angle, relationships. So if you have parallel lines, then you have certain angle relationships. Another way to look at it is if lines are parallel, you're going to have a bunch of things either congruent or supplementary when lines are parallel. So here's an example right here. Angles that are always congruent, so let's trace here. If these lines are parallel, which I tell you they are, then these angles are going to be congruent. Ready? Alternate interior angles, an example of that would be these guys. Alternate exterior angles would be congruent. An example of alternate exterior would be these guys. Corresponding angles, one's in, one's out, same side. An example would be these guys. And then vertical angles are always congruent. An example of vertical angles would be like 2 and 4. Consecutive interior angles add up to 180. Consecutive interior would be like 6 and 7, add up to 180. And then linear pairs are always adding up to 180. An example of that would be 8 and 9. Now, having all these relationships, let's find everything possible. Step number 1, most common is going to be right here, armpits of the Z. That's the most common, that's the most important. So if this is 56, angle 1 is also 56 degrees. Corresponding angles, if this is 56, down here, this is also 56, angle 3. Alternate exterior, that 3 is 56, that means 12 is also 56 degrees. Linear pairs, we go like this. Let me keep the color straight. Let's make that yellow. If that is 180, we're going to do 180 minus 56. Get 124, so of course this is 124. That's 124. Careful here, this entire 5 and 6 together is 124, and then 10 and 11 together is 124. What else can you find? Well, watch out here. We have armpits of the Z. So that means if this is 42, this is 42. And vertical angles, 10 is also 42. And 9 is 42 degrees. You got the 180 there. So 180 minus 42. We get 138, which means this is 138 because it's vertical, which means right here, this and this together is 138, which means 11 and 12 together are 138. But wait, there's more. Take a very close look at these two angles. We're going to get that by getting 124 minus 42. So 124 minus 42, that's going to be 2. We borrow, that's going to be 82 right there, as well as that one. So there is a ton of information. The minute I tell you lines are parallel, all of these angles are fair game. Question is, how do you know they're parallel? This is why it's called proving parallel lines. So last class, we said this. If you have parallel lines, then you have all kinds of certain angle relationships. Another way of saying it, if you have parallel lines, automatically you have a bunch of angles which are either congruent or angles which are supplementary. That's last class. If parallel lines, then angles. Last class. This class, we're going to go and talk about the converse. So the converse says this: if I have a certain set of angle relationships, then it forces lines to be parallel. Or if I have a bunch of different kinds of angles which are either congruent or supplementary, it's going to force parallel lines. So last class was this: parallel lines, if parallel lines, then angles. This class says, if I have these kinds of angles, then the lines have to be parallel. That's called proving parallel lines. Let me give you an example. Last class, we learned this. Quick summary, real quick. If these lines are parallel, alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles would be congruent. That would be like 8 and 4. One's in, one's out, same side. And if lines are parallel, these angles, consecutive interior, which would be 3 and 5, 6 and 4, are not congruent. They are supplementary, which means they add up to 180. Consecutive interior sum 180. That's last class. This class says this: if I drop down a stir stick, and if I notice alternate interior angles are congruent, then it forces these lines to be parallel. If I notice alternate exterior angles are congruent, then it would force these lines to be parallel. If I notice corresponding angles being congruent, then the lines would be forced to be parallel. Last but not least, if consecutive interior angles are supplementary or adds up to 180, then the lines are parallel. Notice we're ending with the proof that you have parallel lines. So that's the 4 of the converse of the previous class. And then there's one more that says this. One more simple one. If lines are parallel to the same line, then those lines are parallel to each other. For example, if I tell you that line L is parallel to line M, and line M is therefore, I'm going to do the arrows, one arrow, one arrow. Line M is also parallel to line N. Notice the overlap here, line M, so they're parallel to the same line. Therefore, you can conclude by transferring the fact that line L must therefore be parallel to line N. That is called the transitive property of parallel lines. So 2 lines parallel going this way, then these 2 lines parallel, and they're parallel to the same line, parallel to the same line. That means these 2 lines must be parallel to each other. That's called transitive property. What does this look like? Go to this page and get your stir stick out. All right, watch carefully. We're going to do this together. Okay. It says in the diagram above, if angle 1 is congruent to angle 4, we're going to sweep and mark angle 1 and angle 4. Okay, and we're saying they are congruent. Now, you want to put the stir stick so that it is physically touching both angles. So I'm going to put my stir stick right here. Ready? Watch what I do with my fingers. So my 1 and 4 are right here. My 1 and 4 physically touch the stir stick. My 1 and 4 are also connected to these lines. Look at my fingers. Super important you look at my fingers here. Do exactly what I'm doing with your fingers. If 1 and 4 are congruent, that forces these 2 lines to be parallel, which would be PS, I'm going to keep it here, and RQ. If these are congruent, that forces PS and RQ to be parallel. And the reason why would be because if these are congruent, alternate interior angles are congruent, therefore the lines are parallel. So I would write it like this. If alternate interior angles are congruent, then I must have parallel lines. I know that looks strange. Let's do another set. Ready? Same diagram. Now 2 and 3 are congruent. So mark 2 congruent to 3. Your stir stick still lays down and touches both angles. We are told that 2 is congruent to 3. It's our second set. Put your fingers right here. If 2 and 3 are congruent, look at my fingers, then it is PQ and RS that are now parallel. Why? Because that's what 2 and 3 are connected to, and they are alternate interior angles, but it's going the opposite direction. So if these 2 angles are congruent, these 2 lines are parallel. Which segments must be parallel? PQ must be parallel to RS. And the reason is, if alternate interior angles are congruent, then you have parallel lines. Proving parallel lines. Let's try another set. This one says do it on your own. I don't think you're ready to be on your own, so I'm going to do this with you. Okay, so you can just follow along, but still have your stir stick and still have your colors handy. In this diagram, 2 and 3 are congruent. Let's mark it. 2 and 3. And you're told that those are congruent, so mark them equal. Now, your stir stick must physically touch both the angles you're working with. So it's going to go right here like this. Touch 2 and 3 with your fingers. Those are alternate interior. They're between the lines, opposite sides stir stick. Look at my fingers. If 2 and 3 are congruent, these are the lines that must be parallel, even if they don't look like it. That's super important. Touch 2 and 3. Watch my fingers. Do the same thing with me. These must be the parallel lines. And so the parallel lines are going to be BC, parallel segments, excuse me, and DE. And the reason is alternate if alternate interior angles are congruent, then you have parallel lines. Let's try another set down here. This one, angles 1 and 2 are congruent. So we're going to mark them. 1 and 2 are now equal. So double hatch. Your stir stick must touch 1 and 2, your transversal. So your transversal is now like this. And in this case, touch 1 and 2. If 1 and 2 are congruent, trace your fingers. Do you see that your parallel lines have changed? Why? Because your transversal has changed. Your parallel lines are now AB and CD. So AB, the segment, in this case, must be parallel to CD. AB, CD. There's your stir stick, and the reason is if alternate interior angles are congruent, then you have parallel lines, proving lines parallel. Let's continue with our theme of proving lines parallel. Remember, there's 5 ways to prove lines parallel. Alternate, let's just count them. Alternate interior angles congruent, lines are parallel. Alternate exterior angles congruent, lines are parallel. Corresponding angles congruent, lines are parallel. Consecutive interior angles supplementary, lines are parallel. Last one, the transitive says if parallel to the same line. This is parallel to this is parallel to that, then the top, those are parallel. parallel to the same line. That's called the transitive property. So that's 1, 2, 3, 4, and 5 ways to prove lines parallel. We're going to talk more about proofs. Remember, proofs are just explanations. There's actually 3 kinds of proofs. We're going to introduce them right now. One is called the narrative. One's called 2-column, and one's called the web. Right now, I'm going to force you to do all 3 styles. And a couple times in class, you're going to be required to do all 3 styles. You're going to figure out that you have an affinity for, or you prefer one of these 3 styles pretty quickly. So when I give you what's called a blank proof, where I give you a given and a proof and no other props, you're going to start getting a choice between these 3, depending on what your brain prefers. But right now, I'm going to show you the same proof, 3 different styles, just so you're familiar with it. For the narrative or the paragraph, you simply write out your thoughts. I know this because of that, this because of that, finally, etc. So it's like literally writing a paragraph. For the 2-column or the web, you're going to follow a little bit more of a structured format. The 2-column, the how goes on the left, and the why goes on the right. Traditionally, we call that statements and reasons. It reads like a sentence. It reads like this. I know this is true because of this. That's a 2-column. In webbing, which is something new to you, the hows go in boxes that are connected by the web, and the web, the connection between one versus the other, that's where your why goes. This won't make any sense for the moment until we do a couple. You got a packet called your DPTP. That stands for definitions, properties, theorems, postulates. You should probably have that close at hand and find this page, if you can, how to prove lines parallel. You ready? Watch carefully. Given, implied, freebies, talk through. Given. We are given 1 and 2 are congruent. We are also given 3 and 4 are congruent. Knowing this, your ambition is to explain how you know that therefore line L and line M, knowing this information, are parallel. How do you know that's true? Implied. What is true? If you have armpits of the Z going on here, which are congruent, that implies L and N are parallel to each other. Just going like that. Then you have armpits of the Z going this way. That implies the fact that N and M must be parallel. Notice the double feathers. So I know that L is parallel to N. I also know that N is parallel to M. That's implied. Looky there, see that? Transitive property. If I have 2 lines See if I can hold this with my stir sticks. If I have two lines parallel to the same line, do you see that? Two lines parallel to the same line? That means those two lines are parallel to each other. That's called the transitive property. So, boom, you have transferred here. Now we're going to write a narrative proof because of that. I'm going to type, since my handwriting is so horrible, we're going to start with the given information. Let me make this a little bit bigger. You can see this here. So get ready to write, because I'm giving you an example. Okay, we are given line L is parallel to line N because it is given, so, no, it's not given. Take that back. You are not given that those lines are parallel. It's the other way around, excuse me. So it is given that angle 1 is congruent to angle 2. So line L is parallel to line N because if alternate interior angles congruent, then lines are parallel. That is your step 1, is we connected. Angle 1 is congruent to angle 2 because of the given. Therefore, L and N are parallel because of the alternate interior angles. There's your first sentence. Number 2, it is given that angle 3 is congruent to angle 4, so line N must be parallel to line M because if alternate interior angles are congruent, then lines are parallel. Can't type a congruent, so I'm just going to add the little congruent. That's number 2. Look very carefully on what's being repeated here. Okay. L is parallel to N, N is parallel to M. Therefore, we can connect L to M, which is exactly what we're trying to prove. I'll do this in red because it's our punchline. Finally, line L is parallel to line M because of the parallel transitive property. Ta-da! You're done. 3 sentences. You've made an explanation. Good job. Now I'm going to show you the exact same in a 2-column. Let's mark what's given again. You're told 1 and 2 are congruent, and you're told 3 and 4 are congruent. That's your given. Because 1 and 2 are congruent, that gives L and N as parallel. And because 3 and 4 are congruent, that's going to give N and M parallel. So we usually start with our givens. So because 1 and 2 are congruent, then we know that line L is parallel to line N. And the reason is if alternate interior angles congruent, then parallel. I'm going to shorten that up just a little bit. Because of 3 and 4, I know that line N is parallel to line M. And the reason is, if alternate interior angles congruent, then I have parallel lines. Notice right here, very important, notice how N is repeated for both. Since N is repeated for both, that means L and M have to be parallel. Line L is parallel to line M. Why? Because of the transitive property. So that's the 2-column version of the exact same thing. I'm going to be quiet. If you need to, pause the video and get this copied down. Webbing. Usually only a small minority of my students like webbing. Webbing is the only style of proof that shows how things fit together. Neither the narrative nor the 2-column shows physically how things interpiece like a puzzle, but a web does. It's very unique. So I'm going to show you how a web works. We're starting with the same given information, the fact that 1 and 2 are congruent and 3 and 4 are congruent. So the web shows how things connect. You put the how in the boxes and the why outside the boxes. So I do something like this. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. There's your hows, and your why is you simply say, well, that's given. That's given. Now, logically, because 1 and 2 are congruent, then we know lines L and N must be parallel because of alternate interior angles. So we write it like this. Line L is parallel to line N. And then you put the reason in between. Watch. If alternate interior angles congruent, you can abbreviate to your heart's content, then you have parallel lines. 3 and 4 make N and M parallel. Line N parallel to line M. And the reason is the same reason. If you have alternate interior angles congruent, then you have parallel lines. Now, we've gone like this. Given, given, implied by the given, implied by the given, 2 sets of parallel lines. Then the web shows how they fit together. This is the only one that shows how they fit together. Look very carefully. You can see it right here, the fact that N is repeated for both. Therefore, you can conclude that line L is parallel to line M, which is exactly what we're trying to prove. And the reason is, what allows us to transfer that parallel is the transitive property. Just like you can transfer congruency, you can transfer the parallelness, if you will. That, my friends, is called a web. It is the only one that shows how things fit together. Do a summary of what you've learned today in your own words.